Welcome back to our study of the derivative, and today we'll talk about a popular type of word problems that are worked in relationship to derivatives and derivative applications. And these type of problems are called related rate problems. Okay, related rate problems. And you recognize these when you're given a word problem. And let's just break it down in its simplest form, a related rate. So first of all, what is a rate? What is a rate? In our context here, a rate, typically we're talking about is a function of time and taking, it's like a dx dt. So a derivative of a function x with respect to time would be a rate. Well, what does related mean? Related means we know one rate, so the problem's going to give you one rate. Say they're going to tell you, hey, we know what dx dt is. We might be able to measure that. But we want to find out another rate. We're really more interested in a dy dt. And again, why? I say here why. Well, maybe we can measure dy dt easily, but we're really interested in dx dt. I guess I just reversed my logic doesn't flow with this. We can measure dy dt, but we're interested in dx dt. What might that correspond to? Well, here's an example. Maybe you can measure the velocity of a bike, dx dt. You can measure how a bike is rolling, but maybe you're more interested in a pedaling velocity, or in order to figure out how many calories you're burning. You're more interested in dp dt, but you can easily measure dx dt. So that's what these problems are all about. Again, it's their word problems, and we just need to work these problems and come up with kind of an approach. That's what math is. You're building problem-solving skills, building mental muscle, and we want to tackle these problems. So let's get an approach for those. Okay, here's our first example. You can read this. A man walks along a straight path at a speed of 4 feet per second. A searchlight is located on the ground 20 feet from the path and is kept focused on the man. At what rate is the searchlight rotating when the man is 15 feet from the point on the path closest to the searchlight? Okay, how do you start all these things? Well, you've got to kind of translate. I always get a picture. I used to tell my engineers this. The guy who gets a picture first is the guy who solves the problem first. Okay, so a man's walking along a straight path. Okay, he's walking along this path. We need to draw a picture and label variables. I might as well call, when a guy walking left to right, hey, how about we call that X? Searchlight, he's going to start here, right? This searchlight looks like it's here. It looks like that's 20 feet. Say it's 20 feet from there. Kept focused on the man. Okay, so this man's walking here. And there's like a searchlight. Let's see, maybe I'm going to give this searchlight is red. Okay, so the searchlight is that red thing. Remember, he's moving. And again, sometimes it takes a little while to figure out. He's moving this way. The searchlight is focused on him. And it says, at what rate? Okay, so we look at this and we draw a picture. So the first thing is we're going to draw a picture. We're going to label variables, I would say, would be next. So I got an X here, right? Because he's going to give me a speed. He says he's moving at a speed. He's moving in one direction. So a speed being, so we got X. He's moving that way, 20 feet. Okay, they want at what rate is a searchlight rotating? Okay, they want it rotating here, so we want to know this angular rotation. Okay, x of t is a function of time. Theta t is a function of time. Okay, so I drew a picture. I labeled my variables. Now the third thing I want to do is to write down what I know. Maybe I translate text. Translate text into givens, I guess. Given info. Alright. So let's see what we got here. What did they give me? Well, they gave me a speed. What's that? What's 4 feet per second? That looks like that's dx dt. Right, so dx dt is equal to 4, might as well, feet per second. And they also tell me something about when x is equal to 15 feet. So this is going to be they want this to be 15 feet when I measure this. What do they want? At what rate? Okay, what are we trying to find? What are we trying to find? This is what we're trying to find. D theta dt. Okay. Okay, we're going to continue on this problem, and I got a new page. Now remember, we read the text. We read the text back here, and we translated this text into what? We drew a picture. Got to get a good picture. We labeled the variables. We labeled this as x. We labeled the we labeled the angle as theta. We put in our fixed distance of 20. And we also wrote down what we know. We know dx dt is 4 feet per second. X is 15 feet. Okay, the next thing we want to do, this is a related rate problem. We know the rate dx dt. They want us to find d theta dt. Okay, so we need a relationship between x and theta. So this is, and at some point I'll give you a bunch of these, but and we got a triangle here, right? We got triangle trigonometry. That's a right triangle. And what do we got? We got opposite over adjacent. Opposite over adjacent. Well, that looks like the tangent then. The tangent of theta is equal to x over 20. Okay? Now notice I don't write this down, but x is changing with time, and theta is changing with time. That's kind of implied, right? So I've got, I found, that's my relationship. And again, this could be the hardest part of the problem. Taking the word problem and figuring out the relationship here is really most of the battle. The calculus, if you've been doing your homework, you can take derivatives. So the calculus tends to be somewhat trivial. Okay. Now next, what do you think the next thing I'm going to do is? Well, this kind of looks like, what do I want to find? I want to find d theta dt. I've got an implicit differentiation problem. So the next thing I need to do is, take derivative of both sides. Or maybe I should just say, do implicit, take derivative of both sides. Okay, so you've got your relationship. Now what is that? Okay, so what's the derivative of the outside function? Remember what I got here? I've got an outside function is tangent. So the derivative of the tangent is the secant squared of theta times the derivative of the inside is d theta dt. Remember, I'm taking a derivative with respect to time. Is equal to, well, what's the derivative of the other side? Well, it's 1/20. That's just a constant. times dx dt. What am I trying to find? Okay, I go back. Oh, yeah, I want to find d theta dt. Well, let's isolate that. D theta dt then is equal to 1/20th dx dt over the secant squared of theta. We know, though, what? 1 over the secant squared of theta is equal to what? That's the cosine. So it's going to be the cosine squared of theta over 20 times dx d theta. dx dt, sorry. Okay, well, I know what this is, right? This is 4. I know 20. Ooh, what's the cosine of theta? Remember theta, remember they gave us this, they said at, the problem says at x equal to 15. Because it turns out d theta dt is going to change with time. This is a function of time. They want to know what d theta dt is at a particular instant. The instant when x is equal to 15. Okay, so when x is equal to 15, when x is equal to 15, what's the cosine of theta equal to? Well, back to triangle trigonometry. Cosine of theta, remember I'm talking about this theta here, is equal to what? Well, that's equal to adjacent over hypotenuse, right? It's adjacent over hypotenuse. It's going to be equal to 20 over what? The square root of 20 squared plus 15 squared. Okay, numbers aren't real clean, but let's just finish this. Let's put an answer down here. D theta dt then. D theta dt is going to be 20 over 200 squared plus 15 squared. And we're going to square that whole thing over 20 times 4. And that's equal to what? That looks like it's going to be 20 over, I'm thinking 20 squared is 400. It looks like it's 625 times 4. I'm thinking this is 80 over 625. And we can reduce that a bit. 80 over 625, which can be reduced. Let's see if we can match our answer in the book here. We divide by 5 here. We're going to get 16. 80 by 5 is 16 over 125. There you go. And now you get the thrill of success when you find out, sure enough, that's the answer in the back of the book. So again, remember what this process is. Let's just quit. We're going to have to just work more problems. Related rates, meaning you're going to get a word problem. You've got to take a word problem. It's going to give you a known rate. The known rate here was 4 feet per second. And they're interested in another rate. They want the searchlight rotating rate. Okay, they want d theta dt. So you get a word problem, you draw a picture. First guy who gets a good picture wins. All right. Second thing, you label. Label your variables. Okay. Translate text into given information. Write down what you know. Write down what you know. Okay. Next step is to find equations to relate variable. That's the key step. You're doing 1, 2, and 3 basically so you can get 4 done. I mean, if you can write down the equation right away, when you get really good and do a lot of problems, you might be able to skip some of the first 3 steps. But the first 3 steps enable you to do 4. Then you take derivatives and solve. Anyway, these are pretty manly problems, and I think you'll enjoy your homework. See you soon.